All right, today we're talking about our stem and leaf plots, and they're not always our most favorite things to do. I know graphs, because you have to like draw the axes and then draw the lines or the figures or the boxes. It can be a little bit tedious, but it's important, like I said in my prayer, that we have to present info accurately. Okay, speaking of accuracy, look at the bottom of page 25. Do you guys see those two graphs where it says graph A, graph B?
Yes, sir.
Okay. Both graphs are presenting the same information. Same information. They're the same data that they looked at. What's the difference between the two, though? They're the same numbers that they use to get both of those graphs, but there's a difference. All right, Ellie?
The scale of the grades, one's just going, there's 60, 80, 100.
Oh, okay.
The other one, there's 20, 40, 60, 80, 100.
Okay, good. That's the main one. All right, do you guys see in graph A, look at the y-axis. Do you see how it starts at 0 and then it jumps up to 60, 80, 100? Okay, that's not a problem, except look at the next graph. 0, 20, 40, 60, 80, 100. So one's going by 20s, one jumps from 0 to 60. That does happen. But if you're comparing the two graphs, which one tends to show a greater increase as you get along left to right? Which one shows a greater increase?
Grade A.
Grade A, yeah, graph A, yep. They're presenting the same info, but graph A looks like, hey, this student, like if grading period 1 all the way to 6, man, look at 1, 2, and then they're just shooting up there, right? Wow, that's a pretty big increase. But the more accurate graph B is showing it's more of a steady increase, which still increase, not diminishing the increase, but one shows it more accurately than another. Both have the same info. Okay, how do you improve graph A then? How do you make that more accurate? Or how can you explain that to somebody and say, wait, I know it looks like it's changing this much, but here's the reason why. What do you tell them? Hint, it's to the right. You draw graph B. Graph B is more representative. Yeah, I know, that's a tough one, right? The thing is, one is showing, or both of them are showing the same info, but one is showing it more accurately. Okay, so what I wanted to do here is, I want to look at, I just Googled this, most commonly misused information. And then I came up with this. It's from health.com. Okay, these are the labels that people put that are most commonly out there and yet the most commonly deceiving. If you're saying, Mr. A, that's kind of harsh. Deceiving? Yes, deceiving. All right. And you've probably seen these before. All right, so here, all natural. Have you guys ever heard all natural?
Yeah.
Yeah, that means that they're not adding any new, like preservatives or like colors or unnatural items. But technically, since the FDA says it doesn't define that, you can really say all natural and still have preservatives in there. Okay, so oops. All natural is maybe not so natural. By the way, the word all, that's a dangerous word. Remember how we talked about that? Mm-hmm. All students, all math teachers? Well, that's not always the case. Multigrain, you've seen those?
Yes.
Okay, whole grains, popcorn, brown rice, oatmeal, those are good. The more you refine those, the less healthy, not the less healthy, but the less nutritious you get. But do you know that the darker the color of the bread doesn't necessarily mean the better? They add caramel coloring to that bread to make it look darker because then that looks healthier. And you can still call it multigrain. I know. No sugar added, yes. Yeah, you already had a lot of sugar and they're not going to add more sugar, but guess what? There's already sugar. By the way, whenever you see fruits naturally have sugar. So if you look at no sugar added, I mean, that might sound great, like, wow, I'm not going to eat any sugar, and this is really good. Well, it's because they already had sugar, and they didn't need to put more sugar into it. But that doesn't mean it doesn't have any sugar at all. Sugar-free. Sugar-free products have less than 0.5 grams of sugars per serving. You know how many serving? Do you know how big a serving size for Oreos typically is?
7.
Nope.
2.
2. Look at the package. 2 Oreos is the serving size. So you have up to 0.49 grams of sugar. Now, this is what I used to do. When I was first married, we used to buy Oreos every grocery trip, and I used to have it every night. And I was young. I could do it. I could eat Oreos every night. Now I don't even touch Oreos, even though they're so good, because the serving size is only 2. So I think the total fat was like 10 grams of fat for 2 of them. And I'm like, you guys enjoy it, okay? God has given you your metabolism. It's going. Mr. A is not going anymore, so I have to like stay away from these. But sugar-free, guys, doesn't mean that they don't add extra carbs. 0 trans fat, another one. When it says 0 trans fat, that means it has up to 0.49 grams of trans fat. So trans fat is like one of the worst fats you can eat. And you're like, oh, yes, no trans fat. I can gobble this stuff down. When you eat 2 of these servings, you've almost had a gram of trans fat. And remember, serving sizes are really small. So that's another thing that's kind of going against you. Immunity boosters. I don't take vitamins, so I don't know what that's about now. Free range, you've heard of free range chicken. This is sad. Free range chicken, what it's supposed to mean is like these chickens are like roaming out in the farmland and just kind of like having fun, chasing each other. What free range it really could mean is that they're just out in the open. You know how the chickens are usually like clumped together, and when they say free range, that means they're outside clumped together. Free range. Okay, that's nice. These chickens are still upset. Chick-fil-A. All right, fat-free. It says this is a notoriously misleading label. Okay? Fat-free may be true, but when they add a bunch of sugar, what does sugar turn into if you don't use it? Fat. So good luck with that. So a cookie, fat-free. Nice! I'm going to eat cookies. I'm going to eat a lot of them. They're fat-free. I can eat as many as I want. And then after a while, you sit down, you go to sleep. All that sugar is turning into that fat. So maybe it's like fat after a while. Light, another thing, that just means it has a lighter taste, not a lighter on the calorie count. Sometimes that's the same. Huh? If you want sugar, yeah, eat it.
No, what if you like exercise sugar?
Yeah, if you can work it off, then you're fine. Gluten-free. I have gluten intolerance. I'm not up to the celiac part, but if I eat gluten, I feel it. And so when I look at these labels, gluten-free is definitely what I'm looking for. But it's funny because like some sodas say gluten-free. I'm like, nice. Or some drinks say gluten-free. And really, they're putting gluten-free on anything because a lot of foods are gluten-free, and it's just a nice label for people like me to be drawn toward. I love this. Made with real fruit. Yeah. 0.0001 on the strawberry flavor. 0.0001 of pears. They actually got sued, I think. Yeah, class action lawsuit because they, in their strawberry flavored, made with real fruit box, they use pear concentrate. That's it. That's the only fruit. Pears and strawberries are basically the same.
So I don't know how they could have won that case.
No, yeah. I thought it was strawberry. Lightly sweetened. Okay, that's relative. You could say, I mean, if you're eating a donut, lightly sweetened may mean like 2 cups of sugar. Oh, by the way, sweet tea may mean like a couple gallons of sugar.
It's a special kind.
I've made sweet tea, and I'm just like, man, that's bad. I don't drink sweet tea. All right, organic. That's not always true. And the standards are not set. 2% milk has more fat than you think. Fatty acids. Serving size, I'm going to leave it on this one. These are like the Oreos. Does anyone honestly only eat 2 Oreos when you eat Oreos? I don't. I mean, 2 Oreos, I mean, if you do, that's good. But that's based on what people used to eat like maybe even 50 years ago. Less food at a time. And that's what your serving size is based on. By the way, a serving size for ice cream is 1 scoop. And I go, there's this place in Simpsonville off Main Street, this ice cream stand. I don't even know what it's called, ice cream stand. Super good soft serve ice cream. And I get their smallest one, and they're giving me like these 2 big clumps. I'm like, 1 serving, yay. My son probably has a regular serving because it's only one scoop on a regular cake cone. But yeah, I get I get the smallest one. I get these big clumps. They're good. Promotion for them. Yeah.
Yeah, there's a place called Duffers where my mom used to work when I was younger. And one scoop of ice cream is about that big.
Yeah. So, and you can put serving size on that. Man, that is huge. Or you could say it's 3 serving sizes, whatever. That's why on our labels, I wanted you to think, all right, how much would a person actually eat? Like, would they actually eat this little cup of your shake, or would they get like a normal glass full of your shake, and then you give the information on the nutrition facts? Yes, sir.
What if you did Oreos into milk? Does that make them healthier?
If you put what?
Oreos into milk?
Oh yeah, milk's favorite cookie.
Well, I mean, it adds some.
Milk has degrees of fat, but milk is overall good. But the Oreos are still in there, and you'll drink the sugar instead of chew it. Oreos are good. Enjoy it. You guys are young. You guys can do this. You can ask your parents. Some of them can still do it, which is awesome. But most of them are probably saying yeah, I can't do that anymore, and that's all right. That's not the time for us to do it anymore. Now that I'm starting to get hungry. Okay, let's keep going. All right. The whole point of what I was trying to do at this beginning is really to show you guys you reflect God's character, and another character trait is truth. Absolute truth. If I say I've never missed a problem, and that's not accurate, I'm being a liar. I am lying at that point, okay? It doesn't mean I lie in everything I say, but I'm lying because I've missed hundreds, if not thousands of problems, okay? If I say that has no sugar in it, then it better not have any sugar in it. Or I can say it has 0.49 grams of sugar per serving. Now, why do these people or these companies put those on their... Well, there are many reasons. What's maybe one reason?
Money.
Yeah, it's profitable to say no sugar. And then some of those who are like, I hate sugar, they're going to buy that because it says no sugar added in that case. Yep. What's another reason maybe?
Well, they want people to think it's healthier than it actually is.
Yeah, I know you'll buy my stuff, but you've seen those thin Oreos? Oh, this is cool. The thin Oreos?
Yeah.
Okay, yeah, they're thinner. They're if you eat one big Oreo compared to one thin Oreo, or the double stuff, right? Let's go regular to thin. What they're banking on is you just eat more of these. Just eat more of those. And then it'll just add up to the 4 that you would have eaten here, which is a conservative number. You might eat 8 of these little ones because they're thinner. It's just a marketing thing. Anything else?
I have a question.
Yeah, go ahead.
Like candy boxes only filled in halfway.
Yeah, and here's a reason. They are saying they package by volume, by weight. So they're packing a certain amount of weight, but then their box is bigger. And I don't know why they're doing it. Maybe it's because things move around or they need some space. But if they give you this huge box and it's only half filled, that could be slightly deceptive, right? Because, I'm getting this huge box, but really you're only getting that much. I don't know about what they do with that. I don't know why they do that. But it could be slightly deceiving. Sorry? Yeah, bags of chips. And I don't know if that's to keep the air, to keep the bags with some type of air preservative type thing. I don't know. Okay, let's move on here. Let's get some definitions. Data. I talked about data already. That was my rant for the day. I really do, guys. I want you to be truthful. It's very easy to skirt. That means go around the truth. I'll wait. Okay, it's very easy to go around the truth and be a little bit deceptive and call it what we say a white lie. But guys, white lies are lies, and God doesn't tell any lie, nor does he tell especially white lies. He just doesn't do that. So we should reflect him. Data, numerical information. I'll just put numerical info. So whenever you're looking at numbers and they're trying to give you some info, that's data. That's all it is. All right, numerical info. We're dealing with statistics today. And that is a branch of math. That's a branch of math like geometry or algebra. And branch of math, I'm going to shorten this, that deals with collecting, bless you, organizing, I'll put that over here, and interpreting data. So statistics, when you organize, or excuse me, when you collect, organize, interpret, that is statistics. Stem and leaf plots are one way to do that. I'll move this here. Okay. I'm going to scroll down here. So this is what we're talking about today, and we'll do it scattered throughout this year as well with different types of plots and graphs. Okay, this is what we're going to do. Go back to page 25 if you're not already there, and look at the very top where it says Carmela Perez sells artificial joints to hospitals. She often works with the doctors who perform operations to replace joints. So Ms. Perez does a lot of driving. She needs to buy a new car to replace her current car. Before deciding which car to buy, she wants to find out the miles per gallon. Have you ever heard of that ratio? Okay, that's an important one for gas consumption. She wants to know the miles per gallon ratios of the cars she likes. The MPG ratios for 25 cars are listed before. So you guys see at the very top, you see those 25 pieces of info? Those are all data points or pieces of data. All right, 25 of them. Why is it important to collect info? For her, in this specific problem, she wants to buy a car. She wants to make a good decision. All right, but you look at that data. I mean, you can look at the highest number, the lowest number, some of the numbers in between, kind of get a feel for them. But don't I need to organize those a little bit? Yeah, I need to organize them in some pattern that could be helpful. And then when I get it organized, I can interpret. I can look at it and say, all right, that's a good decision. That's a bad decision. Okay, so what we're going to do is we're going to look at stem and leaf plots. And I'm going to give you a few pointers on it. Stem and leaf plot. So you guys have already seen these, but I'm going to give you some help on how to come up with your own stem and leaf plot. Okay, so first of all, the stems are going to be the greatest, greatest common place value. Okay, so you're like, Mr. A, what number should I use for the stem? It's going to be the greatest common place value. Okay, we'll look at that through these problems today. And then we look at the leaves, plural of leaf. The next greatest place value. So if your greatest common place value is the hundreds, then your next greatest would be the, anybody know? So if you're in the hundreds, the next greatest would be
6, 10.
the tens, okay? Yeah. It could be 6.
Hundreds.
So yeah, hundreds, and then you would have the one next to that would be the tens. All right, and then this is something I need you guys to get, which I want to emphasize because I don't want you to wonder, Mr. A, why did I miss a point on this? Because you didn't put a key. You got to put a key. Always include in plot. Always include with plot. So if you don't have a key, you got to lose some points because, yeah, you know, well, Mr. A, I know what it means. Well, great, but did you communicate that with the key? No. It's just like a map. How far is it from this town to that town? I don't know. Well, look at the key. There is no key. Then good luck. You're not going to find out. If there is a key, you can see, all right, an inch is 10 miles. Oh, okay, so now I can measure it easily. So you got to have a key to interpret that data effectively and communicate it. All right. Let's go to example number 1. Let's see how this actually plays out. I'm going to need your guys' help, by the way, because there's a lot of numbers. There are a lot of numbers, and I need to make sure that we say them correctly. All right. So what we're going to do is look at example number 1. Who could read the bold type instructions, example 1? All right, Josh.
Use the information in the stem and leaf plot shown above to answer each question.
Okay. Use the information in the stem and plot shown above to answer each question. Now, do you guys see that stem and leaf plot above it? Like above that problem? On example 1?
Yeah.
Okay. Some of you aren't on there, so it's kind of hard to see it. As you can see through that paper. All right, how did they come up with that stem and leaf plot? Well, that's what we're going to do today. That's like the main purpose of today, this morning, I should say. All right, here's what I'm going to do. Go ahead on your paper, in your notebook. You're going to have stem, and you're going to have leaf. Okay. By the way, stems can be many digits long, usually 1 digit, but sometimes 2 or 3 stems. Okay? Listen carefully, because some of you are going to say, Mr. A, you said leaves can be more than 1 digit. No, I didn't. Leaves are single digits. We list out single digits. Okay? Leaves, single digits. Stems, maybe multiple digits. Okay, but in this case, it's nice and easy, 1 digit for each. All right, on 25, this is what we need to do. The first thing you need to do with this info is look, all right, what's the smallest number in that list? What's the smallest number on page 25? So you're going to have to go back and forth. I'm sorry. What's the smallest number listed on 25? 12. Okay, so, yeah, some of you are like 17, 13. Oh, yeah, 12. All right, what's the biggest number, highest number? 50. All right, so you got a range from 12 to 50, okay? So once you look at that, you're like, okay. Now what I do is I look, what is the greatest common place value? Greatest common place value. Give me the correct number, correct term here. Eli? 31. Okay, so you're looking at like the greatest common number. I'm looking for the greatest common place value. So look at all of them, and they're all of them I think have at least the tens. Okay, that's the greatest one. So these stems are going to be your tens digits. What was the smallest one? 1. And then you had 2, 3, 4, and 5, right? So those are my stems. Nice and easy there. We're going to do it in ascending order, so we're going to go from smallest to greatest. But you can also go descending. You can go greatest to smallest. Doesn't matter, but I think this is clear for everyone. All right, now what you need to do is when we're going through this, you lightly cross out the number when we state it. So like, we're going to go through it and we're going to find all the numbers that begin with 1. Okay? So look at the top row and go across. Is there any 1 in the tens place value? Anybody? None? Okay, second row.
3.
Okay, what numbers?
An 8, an 8, and a 3.
Okay, so 18, 18, and 13. All right, 18, 18, and 13, so I'm going to do this. Okay, and I'm doing this for a specific reason right here. So listen, you're like, what did you just do? All right, I'm going to give you a hint on what I'm doing right now. Remember the key I was talking about? Okay, I'm going to give you the key. This right here, so this right here, means 18. So this means 18. What does this mean? What does this mean? Yeah, and the only reason it makes sense is because I gave you the key. I told you what the key is. So now you're not like, wait, is that 8, 8, and 3, or what's going on here? No, it means 18, 18, and 13.
Why do you not use commas?
I guess you could use commas, but, the reason is, remember, the leaves are always going to be 1 digit, so you know that these are always going to be separate. These are always separate pieces of data. If you use 2 or more digits, yeah, it'd be reasonable to use commas, but here, you can just keep it like that, because you know each digit is its own piece of data.
Right.
Yeah, thankfully. All right, 20s, look at the top, third row. Are there any 10s? 2 of them? Okay, what are they?
17 and 12.
For the teens, are we looking at those still? Oh, wow. 2 and 7. All right, any others? No. So did you guys lightly cross those out? That'll help you to so you don't mix them up or say them again, whatever. All right, let's look at the top row now for the 20s. I need some 20s. Any 20s on the top row? All right, just give me the numbers that would go for the leaves in the order that you find them left to right. Just don't try to get them in order. Just go like, look at the top row. What's the first 20?
8.
8. All right, so we put 8. Next.
6.
Next.
2.
Next.
6.
Next.
6.
Another one? Okay, anything else? Third row? 3? 9? Uh-oh. Oh. Oh. Okay. And I think that's going to be the longest one, so we're good. Okay, 3s, 30s. Any 30s top row? Give me the number that should go with the leaf. 1.
0. 1. 4. 2. 3. 1.
You guys good with that?
Yep.
Okay, yep, looks good. All right, 4s, 40s. I'm on page 25, by the way, if you're like, what's going on? 7?
7. 0. 0. 2.
Were there 2 zeros or just 1?
Just 1.
Okay. And then the 5s, I think there's 1. Phew. Okay, before you go on, I would recommend doing this because these problems are going to ask you specific things after you make the stem and leaf plot. This is what I would do. Count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, count them up, and then you count the data points that they gave you, and they got to match up. Yes, ma'am? Okay, sorry. They got to match up. If you have 1 extra up here, or 1 fewer, or more than that, it's going to throw all your answers off. So make sure this is all accurate. Okay, now you're looking at saying, that's supposed to be helpful. Okay, I need to do another thing. I need to arrange these now from least to greatest. Now I can arrange them least to greatest. Single digits. Okay.
That makes sense.
All right, and thankfully they did that for you. And if you're looking on page 26, do you see right above example 1? Do you see there are 2 stem and leaf plots? One, the top one, is like this, disorganized still. The second one, right above example 1, doesn't that look really organized? That's the one we're going to use. Okay, so I need your help, please. Who wants to help me out listing all these numbers accurately? Okay, Josh, in just a moment. Oh, I didn't have to erase that one. That's okay. All right, Josh, give me all of them in order now. Starting with the ones.
2, 3, 7, 8, 8.
All right.
Now for the 2s.
Mm-hmm.
2, 2, 3, 6, 6, 6, 8, 9.
Okay, next.
0, 1, 1, 1, 2, 3, 4.
Next.
0, 1, 2, 7. 0.
Thank you very much. Now it's okay. I see some things. That helps me out. Stem and leaf plot is now complete. You have your correct stems. You have all the leaves in order. This one is in ascending order, so it's starting from the smallest number, 12, to the biggest number, 50. Do I have a key? This is it, stem and leaf plot. You're like, Mr. A, that took us forever. Well, thankfully today, guys, your homework, you're only doing 5 of these. I'm just kidding. All right, you know what I'm doing? I'm making, some of you are like, wait, what did he just say? All right, listen up. You're doing 1 of these. But you're going to answer a lot of questions on ones that they give you. Okay, you're going to answer a lot of questions like what info is being presented. Okay, here are some things you need to know. Listen up carefully because if you're not looking, I'm going to get this question, I hope, less than 3 times. If you guys can do it less than 3 times among all of you, we'll be okay. Okay, ready? This first row of numbers is called the 10 to 19 interval. This is the 10 through 19 interval. That means all the numbers from 10 to 19, including 10 and 19, would be up here. This one would be called the 20 to 29 interval because all the 20 to 29 numbers in between would go here. What would this be called then? 30 to 39, 40 to 49, 50 to 59. But Mr. Ray, there's no 59 here. It's called the interval where it would go. If there was a 59, it would go here. You guys okay with that? Yes, sir?
What if there were hundreds?
So you would call it if it were 100, it was just like this, and these were the tens, you would call it the 120, the 100 to 110 column or something like that, or the 120.
Well, wouldn't it be 109 column?
How would I write?
109
How would you write that?
Yeah, it'd be 109.
I mean 199.
Sorry, let me answer one question at a time. So your question, what if there were hundreds? So if these were hundreds, these would be the tens, right? So this would be 120, 130, 170, 180, 100. Oh, so it'd be the 100 to 200 column. 100 to 190. 200 to 290, or 299.
Okay.
So, but if
Yeah, I have to think about that because I'm not seeing it up here.
if it was like 102, would you just put 2?
You would put, you'd have to round some of these up. So that would be like maybe it would be put 1 and 0. Yeah, and that's actually a good point. We're going to go through one where we're going to have to round the numbers because you could use 102.5 and then put that up here, but that makes it really confusing. So 102.5 can be rounded to 100, and then you can use that as a stem and leaf plot, depending on your data. And we're going to look at that because some of these numbers are like big or complicated. Okay, but let's look at example 1. This is what you're going to mainly be doing on this lesson. All right, use the information on the stem and leaf plot to answer each question. All right, A, bless you. Which mile per gallon ratio did Miss Perez plot most frequently? All right, so which numbers are repeated the most? 26 and 31. How many times are they both used? 3 times. So you would write 26 and 31, right? That's all you write.
31.
That'd be, for example, 1A. Example 1A would be 2 answers because they're used the same amount of times, 26 and 31. Okay, B. What are the highest and lowest miles per gallon ratios? Well, we already looked at them. The highest one would be 50. The lowest one would be 12. And Mr. A, I didn't need the stem and leaf plot to answer that question. Yeah, you could have done it on your own, but now I can see it very clearly. Okay, C. Each line of the stem and leaf plot represents an interval of the data. In which mileage interval did Miss Perez find the most cars? Good. 20 to 29 is this interval, and it had the most, I think, by 1. Okay, so you just say 20 to 29 interval. That's it. 20/29 interval. Okay, so now you know what intervals are talking about. All right. Yes, sir.
Is there an abbreviation for interval?
Int. INT. You can do that. That's all right. Okay. D. How many cars have a ratio between 20 and 39 miles per gallon? 20 and 39 miles per gallon. So how many of those cars? 15. Yep, and you can count up all these points. 2, 4, 6, 8, 10, 12, 14, 15. So 15 cars in that range. E. If you were Miss Perez, which cars might you investigate more closely and why? These are your answers. These are not like, you must say this interval or you must look at this. No, what would you do if you were Miss Perez? What was her problem? She needs a new car, and what do we know about her driving habits? She drives a lot. She needs a high mileage. So you think she's going to look at these?
No.
No?
Oh, yeah.
Probably not.
No.
Maybe not. I think there's enough to look at these 2 intervals. Remember, she likes all the cars. She likes all of these. So it's not like she likes these more than those. She likes them all. And then she listed the MPGs. I'm thinking like here, you can even, she can go up there, but these are probably the prime ones for her. Now you're thinking, well, if Miss Perez is doing this for work, why can't the company pay for it? Okay, that's true. Why doesn't the company pay? I don't care what. I'll get this one if it's a cool car and they'll pay for it. It's a class number. Okay, so what we're going to do here, guys, is we're going to finish this up after, and then I'll give you your homework.